Hi, my name is Vic,
And I'm Jeff.
and we are EcoFlow, where we make your air much more personal.
In the United States, the commercial industry consumes 1.72 trillion kilowatt hours of energy, 44% of which is contributed by HVAC systems alone.
And that's still 750 billion kilowatt hours. And that's a lot of zeros to consider. It's rather odd that we, as a progressive economy, have not reduced consumption in the HVAC industry. We've recently pulled out of the Paris Climate Agreement, which makes it all the more important to invest in smarter, ecological solutions.
The United States has focused on creating building-oriented solutions. Programs like LEED are focused on the efficiency of a building, as well as how a building can retain its temperature. This building-oriented approach is good, but we can improve these efficiencies by changing the way we approach HVAC systems. According to ARPA-E, by localizing the systems and creating microclimates by making them person-oriented instead of building-oriented, we can actually save 2% of all energy used by HVAC systems.
Now, those are great solutions, but they haven't impacted the HVAC infrastructure at all. We still have to deal with laying out plans before putting together ductwork and provide spaces for larger units. Now, in an ideal world, we would be able to provide thermal comfort to each individual in an office building. In this corridor, we would provide microclimates for each individual at their desk, rather than have the central AC cool one person sitting way at the back.
And this is the problem that we have with current HVAC systems. We're required to heat or cool the entire corridor to ensure that the individual is comfortable. Every point you see is affected. By reducing the distance and providing the microclimate, we not only provide immediate cooling, but we reduce the overall energy needed to cool.
And this is what we kept in mind when we had created our vision, represented by this render. At its base, it's a simple AC unit, located on the left, that routes hot or cold air through tubes and leaves at thermal nodes located in front of the user. We would be able to track the user with the help of an infrared camera and provide cooling or heating solutions based on their heat map. And this is our product. There are quite a few components shown here, but not to worry. We will walk through everything happening here. For now, let's see how it works. First, the HVAC will detect a human and switch on. From there, the HVAC begins to blow out air. To demonstrate, we place shredded paper to show the tubes in action. As I, the subject, am leaning left to right, the tubes follow me as well, ensuring that I'm receiving air wherever I am. When I'm finished with my session and leave, I don't have to worry, the device switches off on its own. In our build, we had the idea to build our project out of the available HVAC parts found in the industry.
We also customize our own parts for 3D printing to retrofit our pieces to the standard HVAC system that we had on hand. This is the IR camera, also known as the fluorolepton. This acts as the eyes of our system. As you can see, the images on the left and right are received by the IR camera. One of the services we run is a person positioning system and average temperature service. From there, we do a thresholding to receive only warm components of an image. The largest connected warm component is the human. Next, we are able to receive the surface temperature of objects within the frame of the human and the central moment, so we know how we should direct the thermal endpoints. Another one of the services we provide is a human detection system. We can detect the presence of a human. Without the presence of a human, we can keep EcoFlow switched off. We use machine learning, specifically support vector machines, and use histogram over oriented gradients as a feature descriptor. We trained the SVM on images with humans sitting in front of a desk and images of the desk without them. As you can see, HOG gets the orientation of each square. The idea is that HOG captures the shape of an object. We can classify how human-like an object is or how non-human-like it is. This is more evident when you see the histogram. When a new image is presented to the SVM, it sees that it will more closely represent a human histogram, and thus classify the image as a human. Next, we'll talk about the architecture of the system. The Raspberry Pi receives images from the fluorolepton. It sends it using 0MQ, our messaging system of choice. We publish the images to our laptop. This is a close-up of the fluorolepton. We communicate using I2C and send the images to the laptop. We have a receiver service that is subscribed to the Raspberry Pi that takes in the images and forwards it to the image analysis. The images received from the Raspberry Pi are then sent to multiple services. For example, the person detection service and person positioning service, as discussed previously. This information is then sent to the hardware controller.
From there, we will move on to the hardware side of things, primarily how the Arduino communicates commands to its associated hardware. Put simply, all communication occurs over serial. But what exactly does this mean, and how? From our hardware controller, we take in the raw data found from our image analysis and translate them into commands to be sent to each hardware component, that is, the damper, pan tilts, and temperature controller. We will go into detail for each of these components. First are the pan tilts. These control the direction in which the tubes will face. As seen in the demo, we were able to see the tubes follow the user based on their position, whether they are facing left, right, or center. Next are the dampers. The dampers control the airflow from the HVAC unit. This way we can open or close vents on a particular side of the damper. Now we're left with our temperature control. We make use of an infrared emitter to send messages to the HVAC unit, customizing the user's temperature preference, fan speed, heat or cool setting, or simply switching it on or off.
And that's our entire architecture. We process images from the lepton, send it over to the analysis aggregator, process it, and send it over to the hardware.
Now what happens from here? Our current build is complete, but it can be made into something much more efficient. The project can further cool or heat an individual at a pace that conserves more energy. This will require more research and experimentation.
As discussed, the goal of the project is to maximize thermal comfort and minimize power consumption. By continuing development in this area, it is possible to have a significant impact in the current HVAC ecosystem.
Once again, my name is Vic.
And I'm Jeff.
And we are EcoFlow.
Your space,
your air. Thanks.